Hey, what is going on? It is Friday, April 29th, 2022. Happy Friday, and welcome to Coding with Chef, where I give you a new coding problem every day, regardless of whether you want it or not. But you really want it. I bet you do. Anyway, so I'm glad for the end of the week. I've got some things going on today I'm going to take care of. Just a little preamble. There's a how do I say this, event later that will help determine my financial future, and I am very excited and nervous for it, and it's actually not a do or die because I have a few such events later on during the year, I guess, that will serve in the same capacity, but whatever the case is, I'll let you know how it goes, and I'll probably be giving more substantial updates in these blogs regarding such life experiences and whatnot. That's it for this. If you, by the way, here we go with the problem. If you like my problems, can you like, subscribe, and comment below and let me know how I'm doing? And I'd appreciate it very much because it would definitely help the algorithm out. Today's going to be a quick problem because I've got a lot of things to take care of otherwise, but it's a good problem, I think. It's called 283 move zeros. Okay, it's one of the early Leetcode problems, and as usual, I have a discussion posted in my Leetcode area, my Leetcode discussion area. We can go into that later. So let's get started. There's 8,900 likes to 242 dislikes, so people probably really like this problem. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Okay, very simple problem statement compared to the ones we've done before. The nums example is, the first example is nums equals 0, 1, 0, 3, 2, 12, and then the output is 1, 3, 12, 0, 0. So that's pretty straightforward, right? Okay, so, if this is indicative of anything, this reminds me a lot of a popular algorithm called bubble sort, where elements are sorted and these elements are bubbled to the right of the array that they're sorted in. Okay, so the thing is, you're not guaranteed that the numbers that are non-zero are sorted, right? This array happens to be sorted, but they do have a relative or sorting order. They have a relative order, right? So 3 could be, it could be 3, 1, 12, right? And then in this case, 3, 1, 12 would have to be in front of the array. Okay, so you're essentially filtering the array, right? So let's try doing this intuitively. I think what we can do is, first, we're going to have to do some swaps. So I'm going to write a swap operation, and this being Java, there's no built-in swap operation like Python, so we have to just write a quick one. So the swap operation looks like this. If you are a fan of ancient computer science techniques, it goes nums j, and then nums j equals temp. Okay, so, and that's it. You're just assigning a temporary value and then reassigning that to the integer that you already assigned to the previous index in the array. Okay, so now to the meat of the array. So first, we're going to have to loop through the array, so that's a given. Nums less than nums.length. I plus plus. Okay, and as we loop through the array, let's try to do this intuitively. Now, there may be some fancy optimized ways of doing this, but the key word is that we do this in place, meaning we can't create copies of things, right? And we can't create extra space. So let's do this in place. And that's why you see the return value is void here, because you're not returning anything. The array is already given to you. It's passed by reference. You're just mutating the elements in the array that's referenced here. Okay, so first things, we're iterating through the array. Now, the first thing I see is that we should consider, we want to push these backwards. We want to move these zeros upwards and push these backwards. So what do we know about the front of the array? the front of the array is going to be non-zero. Okay, so that means that to me it looks like just an intuitive way of doing this is looping through the array. If we find a 0, we want to move it to the front of the array. You know, as far as the front of the array is, we can't go beyond or the front or before the front. And so the first element is 0. That's in the front of the array. The second element is 1, and we want to swap that with the 0 element, right? So let's swap that 1. So this next element becomes 1, 0, 0, 3, 12. And then let's say we iterate to the next element, 1, then we find a 0, so we move forward. We find another 0, we move forward. And then we find a 3, right? So what we should do, what I intuitively can do, is swap the 3 and the 0. So this becomes 0, 3, 0, 12. Then the next iteration becomes 1, 3, 0, 0, 12. Okay, and then next is we do this to the 12. 1, 3, 0, 12, 0. Then we iterate again. 1, 3, 12, 0, 0. Okay, there you go. And that pretty much, I think, solves, right, that's the process. So we're just kind of looping backwards internally for every index we move forward, and seeing if we have a 0 that comes before a number, we keep swapping until that's no longer the case. We kept swapping the 3 until the previous element was no longer non-zero. Okay, and we did the same for the 1 in the beginning, and that was just an easy one element transformation. So what I think makes sense to do, let's try to tackle this intuitively. I'm going to have another index that starts at my current outer index, and then while a is greater than 0, because we don't want to go beyond the beginning of the array, nums j minus 1 equals 0, and nums j not equal 0, swap nums j minus 1 j minus minus. Okay, so basically what I'm doing, in this internal while loop, the nums of j minus 1, that's this previous element, continues trying to swap as long as this is true, the previous element is 0, and as long as the current element is non-zero. So we want to make sure that we're not trying to necessarily swap a 0 with a 0, right? If we didn't have this condition here, we'd keep trying to swap the 0 with 2 zeros in a row. So we don't want to do that. And if it's true that these two conditions hold, then we just swap the numbers, and that will cause the element to bubble up. We move this second index backwards until it's greater than the previous, until it's greater than the situation where you don't have a non-zero previous index. Okay? All right. Let's try running that. Yeah, accepted. And there you go. Not the fastest in the world. There is a linear time operation. I would say this is not exactly quadratic. This could be quadratic-ish in the worst case, but it's not exactly the case. You are iterating through all the elements, so it's definitely super linear. But internally, it really depends on how many zeros you have, right? But anyway, we'll not get too much into that. But we can draw a quadratic upper bound as the worst case, but it isn't the tightest upper bound. Let's just put it that way, I think. Anyway, that's it for this problem. Yeah, so let me know what you think, and I appreciate your time and letting me doing this problem for you and watching my videos. And yeah, I'll see you around next time.